In question number 11, we're not given a side angle pair. It's not a right triangle, so what we want to use are law of cosines. Our law of cosines in this case is we're looking at a side angle side. So what I want to do is the first thing I want to find is the length of the side opposite the angle that we're given. So I really want to find this side A. To find side A, remember you want your A and your side opposite, those to be your side angle pair. That helps me get my numbers sorted out. So when I say number sorted out, I want this side A to be by itself, on the side by itself, equals the other two sides, which are 9, so square 9 and square 13. So it's a lot like your Pythagorean theorem, that this side squared would have to equal to 9 squared plus 13 squared, minus 2 times those same two sides, 9 and 13, times the cosine of the angle included between them, or the angle opposite of the A. So we want these to be your side angle pair. This, I think, is key in getting your numbers in the right positions. Make sure that your side angle pairs are always on the outside edges of your formula. So now we got to do a long calculation to help us find the length of side A. So you can type this all in one entry in your calculator. So we'll go 9 squared, then plus our 13 squared, then minus our 2 times 9, so minus 2 times 9 times 13 times the cosine of 55. Another 5 in there. Enter. Now that's what A squared is equal to. A squared is 115.78. We want to take the square root of that. I prefer to raise it to the 0.5 power to give me the same result. So that means A is approximately 10.8. So A is approximately 10.8 units long. I want to mark it on that picture so that I know what I found. So I got to solve this thing. I got to find all missing parts. 10.8. So now what we need to get is an angle. And from this point on, since I now have this side angle pair, I'm going to shift to the law of sines. It's a little bit smaller and easier to use. So we're going to find the measurement of, remember we always want to find the measurement of the angle that is the smallest angle, so 9. So we're going to find the angle opposite the shortest side, 9, which is B. So I'm going to find angle B. So the sine of angle B is to its angle, side angle pair, which is 9, as the sine of a 55-degree angle is to its side angle pair, which is 10.8. To solve this for B, I have to get rid of dividing by 9, which will be multiplying by 9, so 9 times the sine of 55 divided by 10.8. To get rid of the sine, we have to do the inverse sine. So B is going to equal the inverse sine of 9 times the sine of 55 divided by 10.8. So now we're going to run another calculation. I'm going to do the inverse sine, and then I want the numerator all enclosed in a parenthesis. So I'm going to add in parenthesis 9 times the sine of 55. Close the parenthesis for your sine, close the parenthesis for your numerator, divided by 10.8. Close the parenthesis for your inverse sine, and it says our angle should be approximately 43 degrees. Now we can round these off to the nearest degree. There's no problem with that. So now I know this angle up in the corner of B is 43. Put that away for a second. And I want to mark my picture so I know that I got everything found. This is 43 degrees. The only thing left is to find angle C, and that's a very simple calculation. We'll run our 180. We'll subtract the sum of the other two angles, which are 55 and 43. And that's the last part of this triangle that we were missing. So that last part is 82 degrees, and we've just solved that triangle. Because now I know all 6 missing parts, all 3 angles and all 3 sides.